Okay, welcome to this second video on solving systems of equations. In the first video, we talked about the introduction to what a system was and what it meant to find a solution, which is to find the xy pair or pairs which make all the equations in the system true at the same time. And there are two main methods for doing that algebraically. One is called substitution, the other one's called elimination, and we covered substitution in part one of this video. Today we're going to talk about elimination. Okay, to start with that, remember that we said that the goal, let me jump back here, the goal is to somehow combine the two equations to get one equation so that we only have one of the variables. We have to somehow combine the two equations to get one equation that holds only one of the variables so we can solve for that variable. Okay, substitution is one way. Another way is just to add the two equations. And this is legal to do because if you add a constant to both sides of an equation, you get the same equation. And so if you add an equation that says that, for example, y is equal to negative x minus 3, if you add y on the left side and you add negative x minus 3 on the right side, that's just adding the same thing to both sides. So what we're going to do is we're just going to add the two equations together to get a new combined equation. Right on the left side I have two y's, and on the right side the x and the minus x cancel to no x's, and then I have 1 minus 3 is negative 2. So when I just added the two equations, I got a new equation, and this equation just happened because of the way the two original equations were, that when I added them I get a combined equation where the x's canceled out. I only have y, and so now I can continue to solve for that y and get that y is negative 1, and so the y portion of my solution is negative 1. And then if I need the x, I can go back to either of the other equations. I'm going to take this equation, the top one, then I'm going to substitute that negative 1 in for the y and solve for x by subtracting a 1 from both sides. So I get x equals negative 2, and that would be the x portion of the solution. So this method is called the elimination method because we just add the two equations, and when we do so, one of the variables, x or y, gets eliminated. In this case, we just added the equations and the x was eliminated. Okay, let's try that with this system. Same idea. We're just going to add the two equations. Let's try that. So let's see, I'd have negative 3x's minus another 3x's is negative 6x's. Then I have y plus 2y is 3y's equals negative 6. Wait a second, when I added these, I didn't get any elimination, okay? And that's because we weren't lucky. In this other example, we were lucky because one of these equations had an x and one had a negative x, and so when I added them, they canceled out directly. In this case, I don't have that, right? But what I could do is I could force one of those to cancel. For example, let's say that I wanted the y's to cancel, okay? Right now, I have two y's in this equation, right? And so if I wanted that to cancel, I would need the other equation to have negative 2y's. But right now I have positive 1y. So what I can do is I can multiply this equation, the entire equation, left side and right side, by a constant. I would multiply that by negative 2. If I multiplied the entire equation, left and right, by negative 2, let's write that equation over again. We'd have negative 2 times negative 3 is positive 6x's. Negative 2 times positive 1y is negative 2y's equals positive 6. And then the other equation didn't change, so I'm just going to copy it. Negative 3x plus 2y equals negative 3. And now when I add the two, right, I've arranged it so that the negative 2y and the positive 2y will be eliminated when they add together. And so I have 6x minus 3x is 3x's on the left side, and on the right side I have 6 minus 3, which is 3. And now I have a combined equation where I only have x's. And so I could divide and get that x equals 1. So that's the x portion of my solution. And then I can back substitute, pick, let's say, the top equation, and substitute that 1 in for the x, right? So I'm substituting for this x. So negative 3, I'll put a 1 in for x to find out what y would have to be. And so if I add 3 to both sides here, I get y equals 0. So it looks like 1 comma 0 is the solution here. So you can still get something to be eliminated if you add the equations, but you might have to do something first, like multiply one of the equations by a constant, in this case negative 2. Okay, could be even more complicated. Maybe you might have to multiply both equations by something. Okay, let's actually get the x's to cancel first. It doesn't matter which one I cancel. I get either the x's or the y's could be eliminated. Let's make the x's be eliminated here. Okay, and to do that, well, what I have to do? Well, one way to do that is multiply the top equation by the coefficient of that term on the bottom. So we'll multiply this one by a 2. and then we'll multiply the second equation by the number on the top. That's going to make both of those 6x, right? Now, to cancel, I need one of those to be positive and one to be negative. They're both positive right now, so I'm going to make the 3 a negative 3, so that when I multiply, I get a negative 6x in the second equation. So let's multiply out the top equation. I have 6x plus 10y equals 2. Remember, every single term has to be multiplied by that 2, right? It's legal to multiply the left and the right-hand side by the same number. You got to multiply everything, right? Negative 3 times 2x is negative 6x plus 6y equals negative 18. And so because I've arranged this, when I add the equations now, the x's will be eliminated. And I have 16y equals negative 16 when I add. And so then I can continue to solve here for y and get that y is negative 1, which is the y portion of my solution, negative 1. Okay, then I have to back substitute in order to get the x. Okay, so let's take an equation. I'll take the second one this time. The numbers look a little smaller. We'll substitute in the negative 1 for the y. Okay, so I'm substituting for that y. Then I have 2x plus 2 equals 6, because negative 2 times negative 1. And then if I subtract 2, I get 2x equals 4, and so therefore x equals 2. So the intersection point here is 2 comma negative 1. That's the solution. Okay, here's one more. Take a look at this. Pause the video maybe and give it a try. Alright, same thing. You could choose either one to cancel. I'm going to go ahead and cancel x's again, just because the numbers look a little smaller, and I'm going to do that by multiplying the top equation by 2 and the bottom equation by 5, and I'll make one of those negative. Alright, so on the top I've got 10x plus 6y equals, let's see, that's going to be 28. And then on the bottom I'm going to have negative 10x minus 7 times 5 is 35y equals positive 30. Is that right? Positive 30. Okay. Let's go ahead and add. Let's see, that means these are going to be eliminated. I'm going to have, let's see, 35 minus 6 would be negative 29y, is that right? And then this would be, let's see, 58. Okay, and if I divide both sides by negative 29, then y is going to be negative, and that's 2, right? Negative 2. Y is negative 2. And then substituting, let's take the top equation. Okay, and I'm going to substitute in for y, a negative 2. So I've got 5x minus 6 is 14. If I add 6, I get 5x equals 20. And so x would be equal to 4. Okay, so 4 comma negative 2. Right. Okay, let's see. Let's try this one. Let's see, can we do this? Let's see, we have, well, let's get the x's to cancel again. This is what we've been doing. We'll multiply by 3. Multiply this one by 4 and make it negative. And so we have 12x minus 21y equals 6. And then we have, let's see, negative 12x plus 12y equals negative 24. And if we add, we're going to have, well, let's see, x's are canceling. We have 21 minus 12, which I believe is negative 9 there. Okay. And that's going to be 8 and 6 is 14, so negative 18. Okay. And so y would be positive 2, if I'm doing that algebra correctly. And then picking one to substitute in. 3x minus 3 times 2 equals 6. 3x minus 6 equals 6. If I add 6 to both sides, I get 3x equals 12. Therefore, x is 4. Okay, 4 comma 2. Okay, so those are good examples. You should try going back, pause them, unpause them to make sure that you get those correct. Okay, let's try this one. One more. I'm going to show you a couple special cases, and it's easiest to just try it first and see what happens, and then we'll try to explain why this is happening. All right, let's try to go ahead and cancel. Let's cancel x's again. Okay, so we're going to multiply this one by 2, and that's going to make it 4x. So I think I could just get by with only multiplying the top by negative 2. So let's do that. We have negative 4x minus 4y equals negative 4. And the second equation I didn't change, 4x plus 4y equals 12. And so when I add those, what happens? Well, the x's are canceled, but I have 0, right? I have positive 4y's and negative 4y's, so everything on the left cancels. But I'm left with this, 0 equals 8. All right, well, that's actually an inconsistent result. So we call that an inconsistent result, and we therefore say there's no solution. Okay, let's see why that's true, why there is no solution, why there's no xy that will make both equations true at the same time. Actually, I'm going to go back to the original equation, and I'm going to graph both of them. Okay, let's graph this first equation. I'm going to use the cover-up method, right? If I cover up the y, let's see, I'm going to get 2x equals 2, and so that means that the intercept for this is at positive 1. And if I cover up the x term, I get 2y equals 2, so that's going to be y equals 2. So it looks like this is the line for the top equation, if I were to graph it using x and y intercepts. Right, we can do that on the bottom too. If I cover up the y, I get 4x equals 12, so x would be 3. 1, 2, 3. That's the x-intercept. And if I cover up the x, y is equal to 3 also. You know, if I graph the two lines, I think I can see the problem. Those lines are parallel to each other. And since they're parallel, they will never intersect, and therefore there's no solution. So when you have this case where you have something like 0 equals a number, it means that if you were to graph the two lines, you would find out that those are parallel. So in fact, there's no solution. We would say there's no solution. Okay, there's one other case that can happen that's kind of special. Let's take a look at, here's an example of that case. Let's say here's the two equations, and let's get them to cancel by multiplying the top by -2 again, so that I get negative 6x minus 6y equals negative 6. And then the second equation would be 6x plus 6y equals 6, because I didn't change it. And when I add those together, everything on the left cancels and everything on the right cancels, okay? This is a consistent result, but the problem is everything canceled. And what that means is these are both really the same equation. Both are the same equation, because if I subtracted one from the other, they exactly cancel each other out. So let's actually graph that and see what happens. The blue line here, 3x plus 3y, if I use my intercept method, the intercepts are at 1 and 1. Okay, so that's the blue line. And if I do the same thing on the second equation, hey, that one's intercepts are also 1 and 1. So actually has the same x and y intercepts. It's exactly the same line. And because one line is right on top of the other, if we insist on this being a system, then we have to say that the solution to the system is all of the points that are on the line. So this is kind of complicated to say. What you would say is there are infinitely many solutions. Infinitely many solutions. Right? It's all the points on the line. And I think we'll leave your Algebra 3-4 pre-calculus class to tell you more about how to represent those solutions. What you can say in this case is, though, that since this the equation's completely canceled, 0 equals 0, that you just have the same line. So all the points are in both lines. All right. Just a quick summary of the elimination method. The elimination method, the way you do this is you multiply all the terms of one or both equations by some number that you choose, so that when the equations are added, one of the variables gets eliminated by canceling to 0. Then you add the equations, and you solve the resulting combined equation for that variable. Then you substitute that result into any of the given equations to find the other variable. And it is possible to have no solution or many solutions. All right, there's some great practice problems in the practice worksheet, so give that a try. Thank you very much.